All right, so today we're tackling a really cool topic, a huge revolution that's happening on one of the oldest forms of transport we have, the railway. We're going to talk about how AI is jumping out of the data center and getting its hands dirty right on the tracks. And its goal? To solve a problem that's been driving passengers and, let's be honest, engineers crazy for over 100 years. So let's get right into it.
You know the feeling, right? You're at the station, you're staring up at that big board, and then boom! That dreaded word, delayed. It's a universal frustration. But behind that one word is this massive, incredibly complex engineering puzzle. So here's the big question. What if we could actually see a breakdown coming, not minutes, but days or even weeks before it ever happened?
Okay, so here's how we're going to break it all down. First, we'll look at the problem on the tracks, the old way of doing things. Then we'll get into a smarter way to fix things. After that, we'll dig into how the AI actually makes its predictions, we'll look at some real-world results, talk about the hurdles still on the horizon, and then we'll wrap up by looking at the future of the railway.
All right, Section 1, a problem on the tracks. We're going to start with the old ways of railway maintenance. Because, to really get where we're going, you first got to understand where we've been. For a long time, railway maintenance has really boiled down to two basic and honestly pretty flawed ideas.
So you've got two camps. On one side, there's reactive maintenance. This is basically the if it ain't broke, don't fix it school of thought. You just wait for something to fail, then you scramble to repair it. It's a huge gamble, especially when you're talking about trains. Then on the other side, you have preventative maintenance. This is the better safe than sorry approach. You replace parts on a super strict schedule, whether they're worn out or not. It's safer for sure, but it can be incredibly wasteful. You're throwing away perfectly good parts with tons of life left in them. So you see the problem? Neither of these methods really nails that sweet spot between being safe and being efficient.
So that brings us to our next section, a smarter way to fix. This is all about moving from guessing to knowing. We're talking about a fundamental shift. Getting away from either waiting for a disaster or just blindly following a calendar and moving into a world where we can actually know what's coming down the line.
And that smarter way has a name, predictive maintenance. The whole game changes right here. We're not reacting, we're not just preventing, we are predicting. The entire goal is to use a ton of data, feed it into an AI, and have it tell us the absolute perfect time to schedule a repair. You squeeze every last drop of life out of a part, but you step in right before it has a chance to fail.
Here's a great way to think about it. It's basically like a smartwatch for the entire railway system. I mean, your watch tracks your heart rate, your steps, your sleep, right? All to tell you if something's off with your health. Well, predictive maintenance does exactly that, but for a gigantic, sprawling network of trains. It's a fitness tracker for every single engine, every wheel, and every piece of track out there.
Okay, Section 3, how the AI predicts. We're looking for those invisible warning signs. So how does this whole smartwatch for trains thing actually work? What is it looking for? This is where we get into the nuts and bolts, and for all you engineers out there, this is the really cool part.
It all starts with data. And I mean just mountains of data. The whole system, the trains, the tracks, is covered in these tiny IoT or Internet of Things sensors. And these things are constantly talking. They're streaming real-time information on absolutely everything. Temperature, vibration, pressure, even the structural integrity of the components. Think of these sensors as the railway's digital nervous system, feeling every little thing that happens.
And it all works in a pretty straightforward four-step process. First, you collect. All those sensors are just gathering a constant stream of real-time data. Step 2 is analyze. This is where the AI comes in. The algorithms pour through all that data looking for tiny patterns and anomalies that a human could never spot, like a very specific change in vibration that signals a bearing is starting to wear out. Then, step 3, the system uses those patterns to predict. It forecasts a window of time when that specific part is likely to fail. And finally, the most important part, schedule. The system recommends the perfect time to pull that train in for maintenance, causing the least possible disruption. All right, next up, real-world results. The big question is, does this actually work? I mean, it sounds amazing in a presentation, but what happens when the rubber meets the road? Or, the steel wheel meets the steel rail? Well, the answer is a resounding yes.
And let's just start with the headline number. Some operators have put these systems in place are reporting a reduction in unplanned downtime by up to 30%. 30%! That is a huge deal. It directly translates into more reliable service and way fewer of those frustrating delays we were talking about earlier.
And what's really cool is that it's a win for everybody. For us, the passengers, it's simple.
The trains run on time more often. You get higher reliability, fewer delays. But for the railway operators, it's a game changer. They get to run their whole operation more efficiently, which saves a ton of money. Plus, they get more life out of their very expensive equipment. It's one of those rare situations where everybody benefits.
And this isn't just happening in one place. We're seeing this all over the world. Take Germany, for instance. They're seeing about a 30% drop in that unplanned locomotive downtime. In India, they've rolled out what they call smart coaches to keep an eye on critical parts in real time. And then you have Japan, famous for its mind-bogglingly punctual trains. Guess what? AI is a huge part of how they keep that system running so perfectly. So yeah, this isn't just some small-scale test. It's a full-blown global shift. Okay, let's get real for a minute. Section 5, hurdles on the horizon. As anyone in engineering will tell you, rolling out a brand new, game-changing technology is never as easy as it sounds. The potential here is massive, for sure, but there are some pretty big challenges to tackle.
And these challenges are, well, they're all over the map. You've got the tough physical stuff, like figuring out how to stick brand new sensors onto trains and tracks that might be decades old. Then there's the data itself. Garbage in, garbage out, right? So the data has to be super high quality. But honestly, one of the biggest hurdles is the human one. You have to get seasoned engineers to actually trust the AI's recommendations. That's where explainable AI comes in. The AI can't just be a black box. It has to show its work. Oh, and on top of all that, you have to make sure the entire system is ironclad against cyber attacks. So yeah, it's a lot.
And this brings up a really crucial point, maybe the most important one of all. This isn't about AI replacing human experts. Not at all. It's about giving those experts a ridiculously powerful new tool. The AI is brilliant at finding that needle in the haystack, that tiny pattern in the data. But it's still the skilled, experienced engineer who looks at that information, makes the final judgment call, and does the actual work. It's a collaboration.
So, that leads us to our final section, the future of the railway. We've got this amazing partnership between humans and AI starting to take hold. So, what comes next? What's the next stop on this incredible journey?
Well, if you look at the next decade, it's pretty exciting. Today, we're mostly dealing with predictive alerts. The system flags a potential problem. But fast forward about 5 years, and we're going to see deep integration with something called digital twins. And if you look out even further, maybe 10 years, we're starting to talk about a move towards fully autonomous maintenance systems.
So what on earth is a digital twin? Okay, imagine this. A complete, perfect, virtual model of the entire railway. Every train, every switch, every signal, all living inside a computer and being updated in real time by all those sensors we talked about. What this lets you do is incredible. You can run simulations. You can test out what-if scenarios. You could see what would happen if one specific part failed and watch the ripple effect across the entire network, all without a single real train being affected. It's like having a crystal ball for the whole system. And that brings us to a really mind-bending final thought. When you take this predictive AI and you combine it with digital twins and you start adding in autonomous systems, you're heading toward a truly wild possibility. A future where the railway network itself becomes, well, self-healing. A system that can feel itself getting sick, figure out the cure, schedule its own appointment, and fix the problem before a single passenger ever even knows something was wrong. So I'll leave you with this. What happens when that delayed sign at the station becomes a thing of the past? That's the future we're heading towards.